Okay, so today we are going to take a look at ways to estimate with percents. Remember, the goal of estimation is to make our jobs easier, right? So we want to ideally be able to use mental math. And so with estimation, we manipulate our numbers and make them easier to do in our head. So keeping that in mind, it might feel kind of awkward and clunky at first, and it might not feel very efficient because you're putting in more work, but the more you practice with it and the more you get familiar with the strategies, the easier it's going to feel. So there's two strategies we're going to look at today. The first one we're going to look at is called the fraction method or the fraction strategy. With this particular way of taking note or of estimating with percents, what we do is we're going to round our percent to a benchmark, meaning a value that we are used to working with, right? So it's a common one that we use to measure against, and then use its equivalent fraction. So these are all what we would consider benchmark fractions. So ones that you should be familiar with using and know what, or benchmark percentages, and you should know what their fractions are. So for example, 25% is the same as 1/4. 50% is the same as a half. And 75% is the same as 3/4. Those are probably three of the most commonly used ones. Another good one to know is that 33% or 33 1/3% is 1/3. And 66% we're going to use 2/3 as our fractions. And other ones that are just good to know, 20% is the same as 1/5. 40% is the same as 2/5. 60% is the same as 3/5. And then 80% is the same as 4/5. And because we're estimating, remember, we want to change it so we are always using what we call friendly numbers. So ones that we can easily calculate in our head. So let's look at an example. Say we want to estimate what 65% of 12 is. What I'm going to do first is I'm going to look at that 65% and I'm going to look at and compare it to my benchmarks, and I'm going to figure out which of these benchmarks is closest or easiest to use in place of 65%. So in this case, I'm going to go ahead and use 66%. So we're going to change and use 66%, which as a fraction, 66% is 2/3. Then what I want to do is I want to check to see if 3 and 12 are friendly numbers, meaning in this case, can 12 easily be divided by 3? In this case, yes, it can. So we're going to find 2/3 of 12. And if you want kind of that visual to go with it, okay, we have our bar. Our bar represents 12. Because we're looking for 2/3, I'm going to cut it into 3 parts, or take 12 and divide it by 3. So each part has a value of 4. But we want 2/3, so we need 2 of those parts. So in this case, those 2 parts make 8. So our estimate is 65% of 12 is about 8. Now, you might say, well, what if my benchmark that I round to isn't compatible or isn't friendly with the number that's there? So what we do is we just manipulate. So say, for example, I want to find 38 or estimate 38% of 27. So once again, I'm going to look at my benchmarks, and I'm going to say that 38 is pretty close to 40%, so I'm going to go ahead and use 2/5. So in this case, 5 and 27 are not friendly. So I'm going to change my 27 to something that's close to it that is friendly with 5. So I'm going to change it to 25. So now my goal is to find 2/5 of 25. So if we do it visually again, and you won't always have to use the bars, but if they help you, definitely draw them out. So I'm going to split it into 5, but that 25 is then split into those 5 parts. So each part has a value of 5, but we're looking for 2/5, we're looking for 2 of those parts. So our answer ends up being about 10. So that's the first strategy. That's the fraction method. And if I'm honest, I don't use that one a ton. There are times where it is helpful, but I tend to use the second strategy more often. With our second strategy, we're going to call this the 10% method. And the reason I like this one is once you get the hang of this one, it's really efficient because it really comes down to just moving our decimal points around, and I'll show you why. So in the 10% method, what you're going to do is you're going to find first what 10%, which is just 1/10 of the number, and then multiply that for each group of 10. And I promise it sounds more complicated than it actually ends up being. Now, I use this all the time when I go to a restaurant and I have to leave a tip. So we'll say, for example, I went to a restaurant and my bill was $24.75. Now, typically, a good tip or a common tip is 20%. So I want to figure out what my tip is. So 20% of $24.75. Because we're estimating, and even with tips, it doesn't have to be exact, I'm going to round $24.75 just to $25 so it's easier to work with mentally. So first, I'm going to find 10% of $25. If you remember what we did with when we were multiplying and dividing by 100, when we were changing from decimals to percents, remember we always moved it 2 decimal places? Well, it's because hundreds, right, is in our second place value. Because 10% or 10 is our first decimal place value. When I find 10% of a number or divide by 10, I'm going to take that decimal point and I'm just going to move it back 1 spot. So 10% of 25 is $2.50. But I want to find 20%. So 20% is 2 tens. So to find 20% is I'm going to take 2 times the 250. So in this case, it's $5. So 20% of $24.75 would mean that I would leave about a $5 tip. Now, I also use this when things are on sale. So like right now, we're getting towards spring, and so a lot of times winter stuff goes on sale. So say I may be looking for a new winter jacket because they're on sale and I know I'm going to need a new one next year. The particular jacket that I'm looking at costs $80. But today it happens to be 70% off. So I want to know how much I'm saving. So I'm going to find 70% of $80. So step number 1 is I'm going to find 10% of 80. So I'm going to take that decimal point, which is at the end, and I'm going to move it back 1 spot. So 10% of 80 ends up being $8. 70 is 7 groups of 10. So now I'm going to take 7 times that $8 that I'm saving for each 10%, and I find out that I'm actually going to save $56 on that particular jacket.